Hey there, thanks for joining us at the Rabbit Hole of Research, where you'll learn a few facts that you can impress your friends with at a party.
Hey, welcome back to the Rabbit Hole of Research down here in the basement studio. We're all crewed up, got a full house. We got me, Joe.
You got Nick.
We got Nick.
Georgia.
We got Georgia, and we have a special guest with us.
Yep, I am Veeraraghavan, or Psy, the easier version, or Dr. Unpronounceable if I decide to go full evil.
Wait, you said Dr. Unpronounceable? Is that what you just said?
Yep, I've already decided that's the supervillain name.
I
When the
like
day
that.
comes.
There it is.
I love that.
That was in Unbreakable when he goes, I knew I was going to be a villain because the kids all call me Mr. Glass. It's
Yeah.
kinda...
I mean, growing up, like one of my favorite moments from any book was at the end of Watchmen when Adrian Veidt lays out the whole plan and they get all flustered and he's like, I did all this 35 minutes ago. It's just,
And you are a professor.
incidentally, yes, I should say I'm a professor of biomedical engineering.
You're
at
not a
United States
villain, yeah.
University. Yeah, I run something called the nano-cardiology lab where
There
we
it is.
study the nanoscale structure of the heart and how it affects function.
Yep.
So you're just a villain part-time.
Part-time villain. Is that a song like a
I mean, what we do, we
part-time-
call it villainy. That's the
Yeah.
affectionate term for it.
He's a part-time villain.
He's only trying to get control of the tri-state area.
That's right. Yes. Only a little piece of the Midwest.
I don't want the whole land, but I just want this little bit.
Yeah, and we're going to be talking about the heart of a superhero, maybe villains also. So I got I do a little opening, I guess, monologue now. It's been a while since
Yeah,
I've
you-
done this.
You just go for
yeah,
it
just
now.
go for it now. Yeah,
You got me monologuing.
you got me. I the human heart, it's a fist-sized pump, 4 chambers, valves opening and closing with the precision of an ancient machine. It contracts about 100,000 times a day,
Is that right?
sending 5 liters of blood pulsing through 60,000 miles of vessels. A pump, yes, but also a drumbeat, our private metronome. But when we step into the world of superheroes, the anatomy of the heart is only the starting point, because the heart is never only a muscle. In every origin story, every battle cry, every moral choice, the true question is, what does this hero or a villain carry in their chest? A heart burdened by guilt, broken by loss, widened by love? In anatomy, the heart pushes blood. In myth, it pushes meaning. In this episode, we're going to open the chest of the superhero, literally and figuratively.
Wait, we're literally going to crack open a chest?
Oh, we're cracking open some chests.
Oh, I should have brought my gloves on today.
But
You
heroes
should have
don't
worn
beat
that
alone.
lab coat.
Every heroic rhythm finds its counterpoint in the twisted pulse of a villain, and who knows what evil lurks in the hearts of men. The shadow knows.
Are there shadows in hearts?
There are shadows in hearts.
I mean, shadows are produced when light hits something and your heart really shouldn't be seeing any light.
If there
Unless you're a
is,
zebrafish. So yes, there are
Oh, yeah.
shadows in a zebrafish
Oh.
heart. Those things are transparent.
there you go.
Yeah, there you go.
Georgia, how did that line up with what you were reading?
Yeah, did I get it right? All the experts. We got the book.
It kind of looks
Yeah.
like you just took that whole monologue
Yeah, it was
from that.
right.
What's
here.
and Georgia has her
No.
reference materials.
Stop.
A 1958. What's it
Yes.
called? The Illustrated? No,
The Illustrated Encyclopedia of Modern Science.
there it is.
Yes, it has some nice
58.
diagrams.
Nice, accurate diagrams.
Posterior and anterior. And yeah, yep.
I got it. Wow. All right. I do have a list also, but you guys don't.
Yeah.
You may not want
You
my list right
usually
away.
introduce the list a little later.
I do. I have been, but we'll see. Get talking.
So, when it comes to different powers and stuff in a hero or villain, do you think that would affect how the heart reacts? Or is?
Yes. I mean, if quite simply, we are a machine, our body, and whatever it is trying to do is driven by this pump. So what we're doing places different demands on the pump, just on the very basic level. And then there's the psychological aspect. You know, your heart rate doesn't just go up when you start sprinting. It goes up when, so all of a sudden you open your door in the morning, if there's a rattlesnake out there, you're going to feel something. It's going to respond, right? So the emotional side of what a superhero or villain is going through when they're using powers and whatnot, second layer of effect. And then there's the physics of whatever their powers are. That is going to do something directly to the system.
Yeah. I mean, a lot of these we talk about and touch on the biology is that you must change how metabolism works because the calorie load is so immense. But if we just go by the lore of the comics, the movies, we never see that much consumption of calories. And so I think the heart's function, and correct me, I'm not a cardiologist, but its function is to pump blood that's been oxygenated to the various parts of your body to keep you functioning, and then keep separate oxygenated blood and pump it and be the way station for that exchange of blood there going through your lungs and getting oxygenated and coming back. So this pump, because you got to pump the blood from your chest where it's oxygenated down to your toes, back up to your head, your brain, and that takes some effort as you go. The heart is a muscle.
It is one of the 3 kinds of muscle in the body. And, other muscle is skeletal muscle. We have smooth muscle. Both of those types of muscles can do a couple of different things, right? We can squeeze our fist and leave it squeezed so it can stay contracted, or we can squeeze quickly and let go, which is what we call a quick twitch. The heart is a weird muscle. It can only twitch.
Yeah.
It's sort of a single purpose device, but it's also a cool little system. It looks like one pump, but the dirty truth is it's actually 2 pumps that are literally smushed together. There's one pump running a circuit to the lungs and back, and the other one running a circuit to the rest of the body and back with a little connection between those things. And not only is there a demand on the heart with all these things your body would be doing, especially if you're running at super speed or using super strength, etc., your demands are going to be weirdly different. I mean, it is in all of us, right? You want lots of pressure to get the blood up 1.5 feet from just the top of your head, whereas you want to put it in the lungs at very low pressure because it's going into basically a porous bag where it can exchange oxygen and CO2. You don't want to overpressurize it or you're going to drown in your own fluids. So it's maintaining that balance. Scary in a normal person or an athlete. I don't even want to imagine what that would look like if it were the Flash.
I was thinking you mentioned running fast. And we did a speedster episode. Only we talked about the heart, but
I don't think we did.
Just while you're talking there, delivering oxygen to your limbs and muscles that need it without getting that lactic acid burn once you start going anaerobic.
So you bring up a really interesting point, particularly with respect to a speedster like the Flash.
Yep.
They're going to have a big problem with this because Peregrine Falcons have had to develop a solution for this. Those things dive at like 240 miles an hour, which is more than any of us ever do. And they're going face down. And how do you keep that pressure of air going up your nose from bursting your lungs? So Peregrine Falcons actually have a little bone that occludes part of their nostrils. And it's like the scoop on a jet fighter.
Interesting.
So that's something you never see in the comic books. There has to be some kind of nasal adaptation for these guys to not...
Yeah. And then taking in oxygen because the peregrine falcon dives but doesn't continuously dive. It will catch its prey or pull up, right?
Yeah,
so,
and it's diving under gravity, right? It's not exerting for that dive.
So if you're going fast now, you need to either have some hemoglobin modifications also in there that you're using your oxygen much more efficiently that you've taken in, right?
Need at every level because you're going to be limited on the top end by the physics of the lung.
Right.
And so you want better hemoglobin, you want more red blood cells in your blood, but then you want to modify the clotting system so it doesn't clot like when people dope with EPO. There's a whole slew of madness that has to happen to let this work.
Just for everybody, hemoglobin, it's a protein in blood that binds oxygen and then carries that through your body and delivers it. So
that's going to ask that.
I saw your face. I was
like, hold on. You
Nick's
said a few
questions.
words and I'm like, I don't know what those are.
Just
so the heart really makes...
If I say anything that doesn't make sense, just call me out. I'll explain it.
Explain it to me like I'm 5.
So basically the heart aspect of superheroes and other characters really throws a wrench into the plausibility.
A lot of hand waving is happening.
I mean, would
So-
have to alter their heart as well.
There are so
Right,
many layers on which,
yeah.
like, for instance, like the speedsters, again, they start approaching things like the speed of light.
Right. Yeah.
That's just not possible because at the end of the day, tiny parts of individual protein molecules have to move, and they don't move anywhere near the speed of light.
Right. Yes. Yeah. Yeah. I think the same thing with the shrinking and things like that. Once you shrink to such a size,
Yeah.
then oxygen, the molecule of oxygen itself is larger than you have shrunk to. How,
So
how
could
do
you just hold on to that
you know.
and suckle to it?
Did you say
It's even the
suckle?
reverse, right? When you blow something up,
Yes.
there's
Yeah.
a book called Life's Ratchet where this author talks all about the sort of motor proteins in our cells. And he imagines if you took these little, they're like little tubules that go up and down your cells. They're like little highways that are constantly getting built and unbuilt and rebuilt.
Right.
And he imagines, what if that were blown up to the size of an actual street? Turns out those individual molecules that are flying in would be coming in at the velocity of a planet-killing asteroid. The forces that work at the nanoscale, the physics there is very powerful. You can't just pull that apart and say, now you will do this at macro scale, because you'll kind of tear space-time if you do some of these things at that kind of force.
And I will say the heart in other organisms is we're talking about the human heart and then superheroes, but you could scale the heart. That is, whales, they have huge 400-pound hearts and they power a large organism. Granted, it's in water. So once again, they're taking advantage of buoyancy, so that aids them in their propulsion and stuff. But still, they have to pump blood.
Was a heart essentially like the same in each creature, or no? Is it going to be vastly
You just
different?
asked an awesome question.
Thank you. I
So,
tried to.
I'll reframe the question. I'll cheat a little bit. I'm going to reframe the question a little bit. In what way is the heart the same in all the animals that we know of? And that's actually quite interesting. If you look at the unit of what is the single building block of a heart, it is a single heart muscle cell. It's like a little reverse rubber band that shortens when it turns on and lets go when it turns off. And you take 2-3 billion of those, you make a human heart. But the crazy thing is, from mouse to human to blue whale, the individual cell size is roughly the same. They just have more of them in a whale heart by far. And the blue whales will actually their heart can get up to a couple of tons. These things are the size of a beetle.
Damn.
A Volkswagen Beetle. It's massive machine. And sperm whales have not only big hearts, but those things dive to crazy depths. So their hearts are adapted to pump against this massive water pressure. Yeah, whales have really cool hearts. They can slow down the levels that if we slow down there, we're dead.
Man, I actually never really thought about other animals' hearts. Like the idea that they're all essentially
similar, doing the same function. I mean, they're on the opposite end are hummingbirds. So they're really tiny hearts.
Super tiny. They beat it thousands of times a minute. It's
I was
yeah.
I was gonna say it's actually the heartbeat. I just know that like dogs, when you talk about dog ears, isn't a lot of it has to do with their heartbeat?
You mean the number of times the number of times your heart will beat before you die? On
Right.
average?
Like so the rate is very different.
There's a loose correlation. It's pretty loose. In certain species, it goes way off. But by and large, you tend to see a correlation of if you have rapid metabolism, fast heart rate, short lifespan, and slow heart rates correlate with longer lifespans. Particularly, you see this in things like tortoises that have super slow heart rates and stick around a few centuries.
Yeah, you have the same number of beats across. That's the correlation across organisms.
Yeah, that's a little bit of a stretch, but it's roughly
the same. Except humans are like 2-3 times that number across species. So it's really interesting. Humans are a little different.
Human hearts actually are kind of, they're amongst the mammalian hearts. They have a couple of superpowers.
Yeah.
Right? Like, it's kind of funny. Like, this is the superpower you never see discussed in superhero characters. There's nobody I just run at normal speed, but I'm going to run thousands of miles. I'm just a monster.
Super enduring.
But that's actually what we're evolved to do.
Yeah.
We are amazing distance runners. There are these persistence hunters in parts of Africa and like Arctic Circle areas that hunt animals for days.
Yeah.
Just run them until they're metabolically overheated and shut down.
That is an advantage. And
I was thinking it would be a scary power for a super villain. It'd be kind of like one of those Doctor Who monsters that it's not coming at you fast, but they never stop. They're just going to keep
There
running.
actually
Right.
is.
On Grace.
There actually is. And Mike Myers never stops.
I mean,
He is the epiphany of what
Right,
you're talking
Like
about.
a stalker.
Jason, Jason, all the slashers.
Yeah,
you have
they
that.
all
Yep.
do the constant
Yep.
moving towards you.
Yep. Yep.
Like they don't stop. You don't ever see them
don't.
sleep.
It's like a
Yeah.
Terminator.
Yeah, except they're
So when we sleep, does the heart rate get a lot slower?
Yeah. So our hearts are kind of funky in how they're regulated. They don't normally sit at neutral. They normally sit with a little bit of a brake pedal on. They have something called the vagus nerve that tends to slow down the heart. It's normally on a little bit. When we're sleeping, it's on a whole lot more, really calms things down. And then when we get excited, not only does the gas go on in terms of, adrenaline and stuff, but the brake comes off. So that's why the heart can adapt so quickly. Which, again, that's another rate limiting or performance limiting thing, is what is called rate adaptation. Suddenly something happens, we need to speed up, slow down. That is governed by, at the end of the day, some chemical reactions that will take a certain amount of time. That's another thing that superheroes just flying around, dodging, switching directions, they're going to have a problem with.
So it almost, I think, I don't know if I've come to this conclusion over a lot of episodes, is that I feel that the oops, I had licked the rock and got superpowers.
Are you trying to take a jab at me?
No, I'm not taking a jab at
I feel
Owen.
very attacked.
There's
right
no shade at you. I'm just making a general thing that I think the folks who have superpowers that are genetically born that way, probably you can get closer to explaining the adaptations you would need from the heart, from circulation, from oxygen intake, nasal structure, all these, new layers of skin to ooze out fluids or juice your organs.
He wanted to bring that up. Yeah.
First he takes a jab, now he
Versus-
says the words.
Versus
Or anyone that alters their physics fundamentally.
Right,
Because
they
they turn into a gas
right,
or
that's right.
Right,
yeah.
right.
gas.
Yeah, they get
Right,
bombarded
so
by
you're-
cosmic rays.
You're saying like Spider-Man being bit by a spider. All these different things.
Well,
would-
Spider-Man, he had the idea was that he did have genetic change, or whatever the spider injected in him
It changed
caused.
his
Right,
DNA.
he got mixed with the spider, so he took on
Okay.
spider genes. I don't know. That's the
Yeah.
science of that's a little,
Which
maybe CRISPR. I don't.
The closest would be some kind of lentiviral delivery so
Yeah.
that it goes into your somatic and reproductive
right, yes,
and
yes.
it
Now,
would
was
be
it-
some kind
yeah.
of CRISPR type gene
Yeah.
edit, but it would be a massive gene edit.
It would be, yeah. It would have been. He would have been down. He wouldn't have waking up the next day with powers. He probably needed to sleep it off for for some time for that to happen. So you would have some delivery mecanism. You could think of it in a number of ways. I mean, you could have a lipid body kind of delivery. So yeah, you can think of artificial ways to get it in. So that spider, whatever it was, which once again, the animal facility probably would have some issues with just rogue spiders breaking containment. Probably biosafety level 3 spider there, just with recombinant DNA wandering the lab. But yeah, let's say that happened, then yeah, it would be a genetic change. For Spider-Man fits the theory.
So you're saying Spider-Man is possible and I can become Spider-Man.
I'm not saying that.
Let's
definitely not.
like a bunch
I
of
will get
bunch of different spiders to
I'm
bite
down.
you.
While we're on the subject of Spider-Man, for his spider sense, would that be connected to his heart then? Like with how it like slows down a little bit?
The focus, you mean?
No,
Yeah.
So
I mean, honestly, that's kind of a weird,
Because like
misdirects kind of thing. It's so you don't have to slow down your heart to have high alertness, because nerve conduction happens way faster than the rate of the heart, whatever the rate is.
or is it speeding up? Because isn't the spider sense connected to like anxiety?
So so there could be a coincidental increase in heart rate if what triggers his spider sense is that hormonal trigger of anxiety. If he's getting adrenaline, noradrenaline released from his pituitary, and it's going all over the body, medicine. I'm not sure it's the pituitary that produces that. It's the adrenal glands. clearly I'm not a neuro person.
We'll put it in the
I
show
just showed
notes.
my
I
cards.
think. Hopefully, we'll put it in the show notes.
What? I can't believe this. I thought you were.
No, it's your adrenals.
You have another drink, you'll be there.
My biology teachings are just accelerating to near light speed right now.
Yeah. I know.
Anyway, so if those are the chemicals doing the job, then yeah, his
Right.
heart rate would speed up.
Right.
Because I know in the End of the Spider-Verse people, they ended up doing a short film that they showed Miles having anxiety being connected to his spider sense
Mhm.
and it having that correlation there.
Also, just
That's
being
actually cool.
Yeah, and it's always been like that.
But then it's one of those things like which came first. His anxiety caused the
Right.
heart.
I think
The heart, not necessarily the heart rate,
Oh,
caused the
right.
the sense.
Mhm.
Do you see what I'm saying?
yeah.
so that one we can answer. There's chemistry that's going into the blood that's doing all of these things. The chemistry of anxiety. So this is something that is kind of particular to mammals, but worse in humans. Chemically, we use the same signaling systems to indicate things like anxiety as a physical thing, like I'm running or I am being chased
right.
by an actual tiger. Those things get conflated in the brain, in the body, chemically, with I'm worried about somebody or I received bad news of some type, that kind of thing. But with the case of Spider-Man, having this correlation between anxiety and his spidey sense, now it actually brings up a weird long-term problem he might have to think about. The more he uses his spidey sense, the more you expose yourself to these stressors like anxiety, the greater the risk of something called stress cardiomyopathy. Now he's a little bit,
And what is that?
so it's a thing where people who, so there's a version of it that's literally called broken heart syndrome or Takotsubo cardiomyopathy. It is people going through things like extreme grief will abruptly start going into heart failure in a matter of weeks. And if sort of the chemical cycles there can be interrupted, they can also recover from it in a matter of weeks. And one thing that Spider-Man has going for him, unfortunately, over Spider-Woman is women are 5 times more likely to develop stress cardiomyopathy, and we don't know why, than men.
Is that like when a person's partner passes after being together for a long time, the other partner dies shortly
It
after?
is absolutely a contributor to that. Yep, that is a huge element there.
I had a question. This was something that related to heart attacks. I learned this when I was back in grad school, so my memory might be a little shaky. But pre-menopausal women that have heart attacks, usually the mortality rate is much higher than men. And then
You're saying
post-menopausal,
men roughly the same age.
same age. So pre-menopausal women, same age as a man, both have a heart attack. The mortality rate is much higher in the pre-menopausal women. Post-menopausal, the death rate evens out, and it's about the same. And I always thought that was fascinating. And that was back in grad school. I don't know. That fact has stuck with me. And, you know,
Is
that's
that
many years ago.
hormonal
And we still
related?
don't fully understand how some of these things work. Honestly, women's health, particularly when it comes to the heart, is far too much of a black box given the day we live in.
Interesting.
Yeah.
Yeah.
We're only starting to scratch the surface here.
Yeah, same thing with, you were mentioning distance running. There's studies now that women are actually better at extreme distances, like 100-mile races. They actually outperform their male counterparts. Same physical fitness. So men in the short term can outrun a woman. And this is what Sai was talking about, kind of this in the animal kingdom, kind of this endurance. But women really have, between men and women, they actually can out endure. So it really
I thought this was already a thing people knew because horror movies, it's the final girl.
the final. That's
That's
right.
true.
Yeah, there
That
it is. There, made,
Is this not what
Nick
everyone
will
knew?
win.
That is so true.
That's why
So
they can
true.
outlive the
Right.
Jasons and the Freddys
like-
And
the,
those crazy stalkers.
right,
like
right. Or
Myers.
I mean, the real twist would be if the woman is the stalker. Then you would have no chance as a man.
Everyone
We're done. That's
dies.
right. There's no final girl.
You can actually, like, that actually made me think of a weird, like, very slow over time version of an I Am Legend concept where one woman is going through all these movies, killing one monster after another.
That's right.
And
Yeah.
the monsters are
That's it.
terrified. They're like,
Yeah.
she's slow, but she'll get you.
She'll
She
get
gets
you.
there
I
eventually.
love it.
I
And,
don't know
Decades
where
later.
she came from.
and if she's
And that's
slow,
the title of the the graphic novel, right? Eventually.
Eventually.
I love it. And the thing is, she's really slow like a tortoise, so she'll probably live
for, you're right.
a long
Yeah.
time.
And it's
Yep.
just, these ultra marathons, I think that's what they call them. Yeah, no, there you go. We got to get on top of that. We got a couple of stories we got to write down here.
I hope you have them all bookmarked for us.
They're there,
So, like Superman, he's actually an alien.
That's
Has
true.
anyone ever talked about, I'm sure people have, but I am not familiar with Superman's anatomy, and does he have a similar heart?
There's
to
a
humans?
whole book. There's a book on the science of Superman.
I think
I can't remember the name of the author, but if you want, I could run downstairs and get it. It's actually quite a fascinating book. And
all right, you're going to
tries
run?
to
Are we going to time
Are
you?
you
We're going to
gonna run
go.
fast or
Yeah,
slow?
yeah,
Go. Si's running right now.
He's
Can he?
back.
All right.
Right.
That
So
took seconds for Si to come. I don't have my
This is-
phone. You got to take a picture, Jordan. Or send a
yeah,
picture.
so
Send a picture
by
to us.
Mark Wolverton, I'll send a picture to
Yeah,
you.
thanks. We'll put in the
It's
show
called
notes.
Science of Superman, and it's just it gets into every part of it. Like all things, even imagines that there's some kind of bioelectric field around his body protecting him from the airflows when he flies. Like it,
Oh, there you go.
Really
They did
wow.
something on
Does
that.
Does it,
Right.
does it mention the heart?
yeah, and it basically, I mean, you get to cheat because evolved on a different planet. Gets into the sort of gross scale mechanics of his heart, how like, which animal heart it would have to be built like, and so on. We learn a lot from comparing with animals.
Right.
But what it doesn't get into is you would have to have fundamentally different chemistry. Yeah, it would have to be radically different because there are chemical limits, which, I mean, ultimately, again, physics sets the limits on what us carbon-based beings can do as evolved on Earth. Unless he had drastically different chemistry, like some of the stuff Superman does, either he'd have to do that or change the physics of his body in those moments.
Yeah. And probably the safer bet is that he evolved differently. Once again, that genetic factor that on Krypton he developed.
So
They evolved to their planetary conditions.
right. So
Right.
on Superman's planet, everyone kind of has
And you
similar.
Yeah.
and you know what they
Yeah.
are? They would be
Yeah.
extremophiles.
Except a lot.
Is
big.
that right?
Except,
That's how you can say it. Extremophiles. That's the word of the
Oh,
season.
absolutely.
except they'd be a lot bigger.
Yeah, much bigger than
Yeah.
extremophiles on Earth. Yes, yes. He would be a large, multicellular extremophile.
Yeah, there
But
we
yes,
go.
yeah.
we have some of those on Earth, even though they don't strictly get called extremophiles. Some of these little shrimp and fish and stuff they found swimming around these deep sea vents in near boiling water, or some of the
Right.
crazy fish that
Right.
live under the permanent ice in the Antarctic.
Yeah. So yeah, they have their chemistry, their biochemistry is radically different than ours to live at those extreme conditions. So if you had someone living in those conditions and come to Earth potentially, then they could take advantage of whatever changes in gravity, changes in oxygen content in the atmosphere. You could then go,
This
well,
would be
you know,
the ultimate superpower, right? In terms of cardiovascular performance for a superhero, if they could switch chemistries. If they could be, sort of glucose burning, oxygen driven when that's available, and all of a sudden, boom, I can switch into some kind of sulfur chemistry based metabolism if I'm swimming near a deep sea vent. That that would be an all-terrain superhero.
Maybe
They could
that's-
get to some places.
I mean, that's Aquaman.
Who?
Yeah.
Aquaman.
So he might have
like
to have some of
Aquaman?
those abilities.
I was gonna say, isn't it convenient that Superman looks just like humans on
It is a
even
little bit,
though
yes.
every other aspect of him is completely different, but then he looks just
Yeah.
I guess
Unless-
that-
It was initially left as a convenience, and I think at some moments there were some attempts to retcon it and say that the Kryptonians sent out these sort of little, DNA experiment boxes to various planets and hence humans.
Radiogenesis. Yeah. Radiogenesis.
Sort of it's not
That's what that's
panspermia
called.
as much as Krypton's permia theory of human evolution.
Yeah. That's an idea of radiogenesis, is that DNA from other places came and bombarded Earth and started
Or
everything.
maybe-
Yeah. Or
or maybe he's just able to shape shift and look like.
Wow,
you know
you're
what I
giving
mean?
him more
Uh-oh.
powers.
Now we got.
He's not
That's
Martian
that's
Manhunter.
Manhunter.
You're outside of canon now. You're like you're gonna get.
Yeah, you turned him into John
Listen,
Jones.
this is the first episode we've mentioned DC as much as we have.
I know, and
and
you're
you're
like
gonna
already
get us yelled at.
Hey, I'll take credit for that. I'm a DC nut.
So Sai, I do have questions, probably right in your wheelhouse, because you didn't talk a lot about what you study, but what about the superheroes with electric abilities that are sending surges through, Black Lightning?
Yep.
And who has these powers and
Spider-Man.
the effect of that on the heart? And you can actually, I'm giving you an into what you study somewhat in looking at.
I obsess over electrical currents that flow through the heart. These are incredible little processes that, the heart's 3 billion dominoes, and it has to go in just the same sequence every heartbeat. And it somehow does that for a couple of billion beats on the trot in most of us. Right?
Yep.
That is mind-blowing to me. That's what I study. And these people, that are directing huge amounts of electricity through their body in any capacity, whether they're producing it like an electric eel or, they're just conducting what's available. The first thing they have to evolve is amazing insulation somewhere within their body.
Right.
For one thing, we should be seeing these people eating nothing but sticks of butter. The amount of myelin they would have to put around their nerves alone.
Yes.
What Big Macs
They would just
count?
need to eat
Tons. Yeah. Myelin.
bacon and butter
And
all the
myelin.
time.
And myelin is a lipidic wrapping around axons to help the transfer of signal across your body really
That means
fast.
a fat.
Lipids, yes, are fat.
Our
Yep,
brain is
that's right.
60%
Yep,
fat.
That's right. Some people go, you got a big lump of fat on your head. That's probably true. Yes. As a compliment, actually.
Yeah.
Someone told me the other day I have a smooth brain, Joe. Is that good?
I hate,
I don't know what that means,
I
but
hate
yeah.
to break it to you.
Oh, that is an old school insult. That is early 20th century insult.
Yes. But yeah, no, I thought it is interesting that you would have these surges, which then could cause arrhythmias and things like that in the heart.
At minimum, they're going to have arrhythmias, right? They're basically defibrillating themselves every time they do this stuff.
Right.
But past a certain voltage and amperage, the bigger problem is you're just going to burn stuff.
Yeah.
Bags of water.
Fluids.
Like the
That's right.
Will conduct up to a point, but this conductor will burn. It's not like platinum or gold or something that can withstand a lot more.
Yeah. Yeah, no. What are you guys laughing about?
Oh, about combustion
Oh,
and just having our foot left here.
Just a foot.
just a foot. Oh my gosh. Spontaneous combustion throwback to episode
So
with
I
the-
did think of a reference to heart in a superhero type. Although I was thinking of Iron Man.
Yeah, the
Because-
artificial heart. Yeah.
Because Iron Man, of course,
Yeah.
he's not a superhero in a traditional sense. I don't know if there is a traditional
I guess he
sense.
is. And you mean he doesn't have
I mean,
his biology hadn't been altered. Yeah.
he's basically
Right. Yeah.
a human, and
Yeah.
then this happens. So how plausible is that scenario?
You mean artificial heart scenario, or
Keeping shrapnel away from your heart scenario.
you mean with the
Just the whole,
electromagnet?
just the whole.
Yeah.
Just Iron
There's
Man
a
in general.
whole bunch of pieces here that are interesting, right? So literally, let's start with the shrapnel. In the original version, in this part is extremely implausible. They said it had started to penetrate his heart,
Right.
and it was stopped by the electromagnet just short of going through the wall and making him bleed out. But if that's the case, his heart is contracting with shrapnel in the muscle. It's injured. It is constantly being injured. That's okay. Let's assume it didn't hit the heart. It stayed out. We stop it there. Plausible. That could work. But he would need some kind of chemical augmentation or biochemical or gene editing augmentation of his heart to withstand the crazy workloads he's putting himself through. Just controlling the suit, just the speed of information he's processing. And even with all the cushioning, there are the crazy forces that he's getting subjected to.
Oh yeah, the G
Flying,
forces.
getting hit, getting knocked about.
Like the amount of padding he'd have to have in that to withstand the G forces that he's able to pull is revolutionary in and of itself.
The other thing they don't talk about is dissipating the heat load from the arc reactor that's strapped to his chest. So to do all that work,
Wait, I thought that was
you
clean.
need to even any energy, energy conversion usually it's not 100%, and so there's waste involved, and that waste is usually heat. And so to power something like that, the energy input and output, you would generate a good bit of heat either way. So having that strapped right
Even
to
if
your
you
chest.
assume there was monstrously efficient,
Yeah,
and let's assume some freakish, violating thermodynamics, 99.9% efficiency, it's still a bucket load of heat. Like he's gonna need to drag a server farm worth of fans behind him.
He needs that extremophile.
He needs to become an extremophile, that's right. And so he would need to have some genetic modification. So he might be a superhero another way. I always talk about that we have the genotype and phenotype. And sometimes you don't know you have a particular genotype because you're not challenged.
And
Could Tony Stark
and then it gets turned on.
Also, with that much heat evolution, he would have to stop and refill coolant in a suit, even if the fuel never ran out.
Yeah.
He'd have to stop every little bit and go, okay, I need more liquid helium in here.
But he could have an adaptation. So in a world, you know, Tony Stark lives in a world where the X-Men live. So he could be a mutant and just not feel the heat load, or has some sort of modifications in himself to actually process that. And he's
possibility is if his nanotechnology is developed advanced enough, you could assume he's just re-upping himself with some kind of nanotech way that's constantly repairing his body. Just eat the damage and be absorbing it and repairing on a molecular level.
Then you're getting to the gray goo theory if that gets out. And the gray goo theory is the one where nanoparticles, machines break free and try to take over the world.
But Michael Crichton's Prey, I think, what was it, Prey or different one?
It might have been Prey. I think it was.
It was Prey, yeah.
I always think of Blood Music. That was one early one with gray goo theory. But yeah, I'll throw that in the show notes, or at least I hope. And better at the show notes. But the heart, you're right. It's Iron Man is there. Darth Vader also had a mechanical heart. His heart was replaced.
It's an interesting parallel we could study to understand what these particular characters would go through, which is, what we have from medieval sword manuals and such about fighting in armor. And what they said, and historical records of what people could and could not do. One of the things they could not do is run any real distance. All the things in like Lord of the Rings and all those movies where there's people in armor just bolting across a field, they would go there, be tired, and not even need to be fought. They would just collapse.
And no one wants to see that.
No, that's not a
What a
movie.
sad
They're
chart.
just slowly moving.
Movies don't even do anything.
That's
I'll
not a
get there.
fun
Don't
movie.
worry.
That's a long movie.
And
This
Tony
movie
would
is-
have a real problem in his Hulkbuster armor because the scale of that thing.
I think that was the
He's moving
mechanics.
weird.
I mean, that's all the energy to move all those mechanical parts.
Yeah.
And that's why they switched it to the nano suits, right? Because then you would free up, that would be a natural kind of flowing, fluid kind of suit. But the Mark 1 that he made in the cave, we're going, that was, that was made out of iron. I mean, that was right. I mean, that was just a heavy piece of equipment.
And would also be very susceptible to certain very easy attacks. You wouldn't need to do anything serious to Tony. Just screw up one of the major joints on his suit and run away.
Yeah, that's it. I mean, you got to get close enough, but that's it.
Right.
I mean, that's
Put an SUV into Iron Man's knee. You're dead. You just walk away.
So I do have a question about an episode that we had done earlier this year or maybe last year. I don't remember time. But
is it a time travel question?
No, it's a Doctor Who question.
Oh,
having two hearts actually do anything to better a body or no?
So Doctor Who has the two hearts, and it came up in a Doctor Who episode earlier with Tara, and I touched on it and I had some ideas. But yeah,
I mean, octopi have three hearts. Like one is just distributed processing, right? You let each heart handle the load for a part of the body, and therefore doesn't have to pump that hard. And it would actually help explain some of the longevity that you see from the Gallifreyans, the Time Lords.
Yep.
That if you had two hearts and neither one is actually redlining as much at a given moment, you're going to actually extend your lifespan. You're going to go tortoise mode.
Oh,
Interesting. Yeah.
So if I go ahead and crack my chest open to put another heart in, I can live longer.
I would
Yeah.
not necessarily recommend that.
That's right after you
Yeah.
get bitten
The rabbit
by
hole
a
of
bunch
research
of
is not
spiders.
recommending you add a second heart.
So,
There's
Are
some
there,
question of where
are
you're
there
getting the heart.
animals with second?
Yeah, and I'll
two
put it this way,
hearts?
right?
Unless you said the octopus
octopuses.
has 3
Oh,
hearts, right?
okay.
Yep. So, yeah.
Okay.
No, I mean, I'll put it this way, right? There's another game we could play here, and I'll talk about that because it's actually a therapeutic technology called an LVAD or left ventricular assist device. But in terms of adding a second heart, we do it in certain patients, right? That's the LVAD thing, where if their heart is so badly beat up, but they need to wait to get a transplant, it's going to take some time, but we don't think they could survive that window, then they get this LVAD device. And conventionally, it's a larger pump. It lives outside the body. You literally plumb tubing from the pump into the left ventricle of the heart, which is the side that pumps to the whole body, handles the high load, so that the blood that goes into the left ventricle, this pump is pulling it and then pushing it back out where it needs to go. And that's the other end of this pump.
Wow.
That's the smallest we've been able to make it until
Right.
very recently. There is a smaller version of it that is now being implanted in patients undergoing heart attack and treatment for that.
Wow.
And the reason there is also interesting. A heart attack is when a small piece of the heart dies and basically turns into scar. And something funny is these happens. I mean, the funny thing is they happen, first of all, when blood flow to a region of the heart is stopped or inadequate and it's working without supply, it dies. But the funny thing is, when we restore flow, we don't fully understand how, but the damage gets worse. A larger chunk around this region dies. It's called
Wow.
reperfusion injury.
Right.
Wow.
And one solution that looks interesting is there's a way of implanting a tiny pump inside the aorta, the big blood vessel coming out of the left side of the heart, that sends a little snorkel into the heart, sucks the blood out and ejects it. So in that vulnerable time when you're restoring flow to that piece of the heart, if you unload the heart, don't make it work so hard in that vulnerable moment, it seems to reduce the damage. That's the best augmentation we've been able to do. We could build a heart good enough that it would be worth adding to somebody's chest. We'd already be doing it. We just don't have that kind of technology.
Right.
Yeah, Nick,
Wow, interesting.
don't do it.
Don't do it, Nick.
Why? It sounds fun.
He's
Like,
going to get dog
No,
heart.
wait a
Sure.
couple of centuries for the technology to mature.
A couple
Do-
centuries.
I'll wait like a
Tortoise
decade.
yourself.
All
Or
right?
you
Let's-
could do time travel, maybe.
Time travel. Now we're close to some holiday season here.
What holiday season?
The holiday season.
I don't know what you're talking
Okay. I want to ask about the Grinch, whose heart
Oh.
grew 2 sizes.
Hypertrophic cardiomyopathy, yeah. You would have been dead. You had a very brief window after that, man.
So he had a very small heart, which, probably struggling to live. And,
Yeah.
and then
Three
and then
sizes, wasn't it?
was it 3 or 2? 2 or 3 sizes, yeah.
It was,
also
it was
too
two
big.
sizes
size of
too.
heart?
It was 2 sizes too small, and then it grew
Okay.
3 sizes to go larger
Yeah.
than. Yeah, it was 1 size larger than after he
Yeah.
got filled with the spirit, the Christmas spirit. Just
I mean,
dead.
that actually sounds like worse than hypertrophic. It's what's called dilated cardiomyopathy, where the heart has gone big and baggy and is struggling to pump anything.
Oh, no.
He seemed super.
Those are
I
the
mean,
people who usually end up needing the LVAD. That's what we should have seen, the Grinch with an LVAD hanging out.
and the Who
Wow.
people taking care of him, they do the surgery, and then he's very thankful. That's the real.
No, then he
Like,
goes back to being grumpy again.
Maybe that's why he was
No, but then
grumpy.
he can't do anything about it because it's hard to move around with an LVAD hanging out of your chest and a battery packed on your back.
And maybe that's why he was grumpy at the beginning. He had this little heart. He's deprived of oxygen. He's just, just
Is that why
angry.
he's green?
Maybe that's
Maybe
just
that
why
is
he's
why
green.
he is green.
Or would you?
Wouldn't you
should
be
it
blue? I think, yeah, you'd be blue, yeah.
So,
I don't know.
Yeah.
I'm not a doctor.
so why do you think we are so romantic about the heart? Like we have made it
Oh, that's a
into...
great question,
Yeah,
right?
definitely.
It's all over poetry, literature. It's
Mhm,
everywhere.
mhm.
We associate it
Yeah.
with emotion.
Heart of gold.
I think it's one where we are led to think that way because the heart is one of the places we feel it.
Mhm.
Mhm.
When you have
Mhm.
emotion,
Yep.
you are having 2 things happening. One is your autonomic nervous system. You get excited. This is the nervous system that connects the base of your brain involuntarily to your heart so that it can adapt. So the heart's, I'm going to back up a little bit because I like the science here. And I think the heart's a cool little machine, right? This thing, you can pull it out of the body. It doesn't need the brain to tell it what to do. It'll keep
that's right.
pumping.
Yep.
It's self-sufficient. And it's self-adapting. In transplant patients, we don't know how to reconnect the nerves to their heart. Their hearts, the new heart that a transplant patient gets, is beating away, we think mostly without any input from the nerves in their body. But it will still adapt when they start moving, the heart rate will go up. When they sit down and really chill and, start dozing off, their heart rate will drop. All of these things are happening because the heart is tuned by the amount of blood getting into it on a given beat. Yeah, it just has a simple thing of whatever comes in, I'm going to pump it out. And that is the mechanism by which it adapts. On top of this, we all have another layer of control. Actually, 2 more layers of control. There's chemicals coming in through the blood. You get excited. If you get really excited or scared, you might have felt this bitter taste in your mouth. You're literally tasting the effects of a huge adrenaline jolt. That would also be a moment where you feel it in your heart. And so people talk about the bitter taste of defeat. Yeah, they're tasting, not just incidental. In the same way, they're feeling their heart respond to their emotional tones because of both these autonomic nerves coming in and, electrically stimulating or electrochemically stimulating it, and the chemistry in the blood. So when we feel emotion, we feel our heart do things. So I think we associate it with where the emotion is happening.
Yeah, it probably, I want to maybe think about it. The heart might have been the first organ we actually knew what its function was in terms of biology.
There's a brilliant book on this by a guy named Charles Singer. It's called A Short History of Anatomy and Physiology from the Greeks to Harvey. And the title's a misleading title in that it starts way before the Greeks even. He talks about cave paintings from 35 to 50,000 years ago, where there are these diagrams of bison and deer, and there's precise diagrams from different perspectives marking with an X where the heart is.
Right.
Wow.
Because that's how you're going to chuck a spear in the right spot and get dinner instead of get trampled. So people started studying the heart very early just to get food and not die. And when we started studying human hearts as well, and there were these scientists back in ancient Egypt that were cracking open chicken eggs at various points of development, figuring out how the heart develops from embryo to, full chicken.
Yeah, no, I
So
think
we've been studying the heart a lot, but there have also been some silly ideas, because if you read William Harvey's book, the first chapter is comedy gold, just comedy gold. He talks about all the competing ideas of what people thought the heart might be doing in certain parts of the world. They thought it was a chilling system for the blood, which needed a refrigeration unit. They thought it was a supplemental lung that it could do extra breathing when your lungs weren't enough. There were some hilariously bad ideas.
They're probably trying to explain superheroes, right? If you're flaming on, if you're running at super speed, you need to have your heart might take on some other function chemically and do it.
All right. So where did the shape, like that the iconic heart shape come from then? It's nothing like the actual heart. Do you have that information too?
The actual, I don't.
I happen to not know this one.
I don't.
Guys, come on. This is why I'm doing this episode.
Yeah.
I think we have to do some more research.
I know. We have to go.
Because it looks nothing like it. And also, another question. Why do people misremember where the heart is on a human?
Say that again, sorry.
Because when, we're here in America, and people say put your hand over your heart for the Pledge of Allegiance.
Oh, everybody puts their hand on their lung immediately.
But that's not where the heart is. Like,
no.
Why do
it's down here?
Yeah.
But it would look, conventionally, from a cultural perspective, it would look like you have indigestion rather than you're, showing respect. Because we associate the pectoral muscle, because that is sort of where you're going to feel the thump of the heartbeat. I think people misassociate that spot. But the heart first of all, it's a cool little thing. It's hanging like in a sling inside the chest, so it can beat freely. And it's hanging, pointing slightly forward and to your left. So it's kind of diagonally sticking out just under your pectoral muscle almost. So if you wanted to really put your hand on your heart, it would look like, get me some antacid now, please.
Yeah. Interesting. I'm looking this up because this is a fun thing in a heart shape. It does have a rich history going back into the Middle Ages, even before that, and looking at it. But some of it's fun. It's based on plants in ancient times, based off the seed of the Silphium plant. And it was an herbal contraceptive. and stylized depictions of features of the human female body, such as breasts, buttocks. The public pubic mound was the shape that stylized into the shape of the heart. So very botanical and female in nature. And it got tethered to romantic love in about 1250s. And
I can see
it's
how
a very,
if you were just imagining, you had never seen a heart, and you were just imagining, I don't know, like the two sides. I think maybe you just imagine that's what it looked like.
a lot of it is like, it was really depicting foliage. That's what, but then it got entangled into love.
Sorry, I don't know if that took us down a weird rabbit hole.
There's also some conventions of art history thing going on.
That's
here
right.
as
Yeah,
well.
no, for sure.
Like, because that symbol has been depicted in sort of Greek vases and stuff.
Yep.
And the Greeks definitely had a very stylized way of showing humans and different things.
Mm-hmm.
Yeah, but you're right. It's not the heart. The actual physical heart doesn't look like the symbol.
Yeah.
And when I say Greeks, I really should be saying the Mediterranean peoples, because this is something I've been, I'm a bit of a history nut on the side just for fun. And I've been learning about how much of what we think of as the Greek and Roman myths are really Mediterranean myths. The other half came from North Africa.
Yes,
Oh, wow.
exactly.
Yeah.
Mm-hmm. Boats have been going back and forth for a long time, along with stories.
Oh gosh, I just read something where someone said like they were correcting the terminology, and it was like it made no sense what we say, or we just get used to saying
something.
We label something, and it's totally inaccurate.
Right.
But because we've said it so much, that's what we.
Of the heart being on the left side, there's a fine example of that in the word we use in a very different way that just means left. Sinister. Dexter and sinister were right and left, right and left-handed.
Interesting.
And left-handed people were considered so evil. The word sinister has come to mean what it means.
Yeah.
Wow.
I mean, I get it. You don't like the left-handed people.
Wow.
In storytelling, you have the removed heart stories or missing heart. And you see that a number of times. The Davy Jones and the Pirates of the Caribbean.
There's that, the Tin Man, or the stolen or preserved heart.
That's right.
Those
Yes.
back was the,
Or Poe.
Fairy tales, the telltale heart, kind of guilt and things like that.
In Arabian folk tales, there's a wizard always whose heart is in a box over the seas, over the seven seas.
Yep. You have it was a Norwegian fairy tale, a giant with no heart in his body, and that was the heart is hidden to avoid death. So that story comes up a lot in fairy tales where you have it. So I think that's really, because then how does one live without this crucial pump in their chest? So I'm going to take this out.
Necromancy.
And then when you put it in a box and you're now immortal, this gets to the heart in the box isn't necessarily beating. And so now you're preserving the beats, and you've now connected your physiology in some way that you're maintaining life, or like you're some sort of magical hand wavium rock is put in its place.
Yeah.
I just said necromancy. I didn't say a rock.
But I thought that was you always want to lick a rock to get superpowers.
I do.
So I'm just going,
listen, I want them. It's not.
But I thought that was another way in the heart and its of its power. And that tether, even then, to longevity was at some kind of fundamental level understood that this was
back to sort of Paleolithic practices of things like eating the hearts of enemies. There was definitely an association between the heart and somebody's life force, somebody's sort of even psychological qualities like courage and their sort of force of character and things like this were considered to reside in the heart. And
I
think it started with hunters eating the hearts of animals because they're rich in minerals. It's very good for your body. Anybody who's from the tropics knows if you're sick, somebody's going to give you a bowl of chicken heart soup and it will actually treat you well. But I think they extended that to the level of saying, okay, now we've defeated our enemies. We want to consume their power. We're going to eat their hearts.
Yes. And it's one of the most obvious, recognizable organs, I think, in the human body. Maybe besides intestines. I think
but also one of the safer ones to eat.
And the safer ones to eat. That's right. Exactly. You can actually probably pull it out, eat it.
Yeah.
And
not that I recommend eating human hearts.
No. Do not.
They should be.
There's a lot
Start
of
with the
disclaimers.
cat,
A lot
right?
of disclaimers on this.
A lot of disclaimers in this episode. Yes, do not. Don't do it.
I mean, okay. I will say, from meat animals, it is a delicious cut. If you read, cow heart or sheep heart,
I
it's
agree.
delicious.
I mean, I prefer the brain, to be honest. But
Oh boy,
what? You don't like head cheese?
no.
Oh boy.
Head cheese is not brain, mostly. Head cheese is just cabeza. It's the outer part of the head. But brain itself is also tasty. But again, you want to source it right.
You got to do the mixture of the two. You got to mix that.
Oh, this brain. Okay, so I didn't realize I was reading brains there as well.
Yeah,
This has
this is a
gone
different
down a
episode.
really
Yeah, we're in some
horrible
other rabbit
rabbit
hole. This is a zombie episode here. I mean, we're getting.
I'm already halfway there.
I was going to say, as a history, you can correct, but the Egyptians, when they mummified, the heart was preserved, but the brain wasn't. Like they didn't actually.
Yeah.
Typically, the brain had no function really.
There's another argument that the chemistry is easier to preserve a heart than to preserve a 60% fat-based brain.
Oh, they didn't have.
Putting the practicalities-
They didn't have glutaraldehyde and osmium tetroxide, obviously, because from electron microscopists, the brain is much easier to preserve. But yeah.
Yeah, in fact, with that stuff, the heart is the harder target.
That's
'cause
right, yes.
I had to cocktail the root with PFA, with paraformaldehyde, so it fixes
And so
reasonably quick.
a little behind the curtain, aldehydes will cross-link proteins inside of cells, and then osmium tetroxide, which I mentioned, actually affixes lipids, so unsaturated double bonds, lipids. And so in the heart, the brain has a lot more lipid, and that's so the osmium will fix that. And it's easier to make sections and take high-resolution images, whereas the heart has less lipid content.
Yeah,
and
the heart is so dense with protein, the fixative will hit the surface of your chunk of
and it's
tissue,
fix really
fix
fast.
it,
Yeah. So it
and then
doesn't
it will
penetrate.
create so many crosslinks, it can't go further, and it gets traffic law jammed on the outside.
Yeah. So it's hard to actually fix the tissue reliably in the process.
Yeah.
So really, from that point of view, the brain is easier. But yes, and the Egyptians probably didn't have. I don't know what they had. I mean, maybe they had aldehydes in some way, but
I think, I think they had access to at least some impure aldehydes.
Yeah,
It's pretty
easy to get
byproduct
aldehydes,
of
yes.
a basic distillation.
Yeah.
And we
So-
know they were making beer. The Egyptians
that's
made
right.
a lot of
That's
beer.
right. That's right. That's right.
So somebody put some of it
and-
in a thing and heated
Yeah,
it.
and alcohol is
I
a
know they
good
did.
fixative. Alcohol is a good fixative, so they could have used that. Yeah, so there was lots of ways. Whereas osmium might have been what they didn't have, so the brain would be very difficult.
Yeah.
There we go. Yeah, and osmium is a mined mineral, so it's mined and extracted.
Not mind.
Mined as in diggers, like
Yep,
Minecraft, which is like Minecraft
Yeah, no,
is
I
actually
was
mined.
thinking
Minecraft,
Mine.
you are digging.
Yes, I always thought
Yeah.
Minecraft was like mine because you're using your mind to
No,
craft.
that's MIND.
I know, but I didn't see the word spelled out for some time. So I thought Minecraft was like, oh, the kids, I want to play some mind. Oh yeah, go. That's great for your mind. And it's
No,
it's
the kids
Yeah,
are
the
for
full
the
version
mind.
is, through telepathic
yeah,
code.
that's exactly right. I'm like, this is gonna be cool. You're learning some, you're using your mind. But yeah, no,
No, they
it's
just
mind,
want to
yes.
dig.
There's no osmium in Minecraft.
Sure, I don't know.
We'll take your word for it.
I don't know.
I guess you played more than me. I don't know.
I was just throwing it out there. I don't. You know how many
It's
video
like
games
in
I
that
play.
little box. Like,
Yes, it's in a little box. Yeah, so we've covered some ground on the
You
high.
never actually went through your list.
Yeah, I mean, we did. We went through the
covered
list.
it.
We went through the list without going through the list because I just had the hearts in fiction and the different motifs we see: extra, multiple hearts. Cover Doctor Who, missing or removed hearts. I kind of scooped that one up. Mechanical, artificial hearts. We touched on that. The symbolically warped heart. We talked about the villain and haunted Gothic hearts. We probably didn't touch on that one as much. Mythic or cosmic hearts, and I had hearts as power.
And the heart is also a symbol of good or evil, right? You have
Right.
the sort of
Right.
golden
Right.
heart or
Right.
of somebody who's good, and the
Right.
dark heart
Right.
of
That's what
you know,
yeah,
so-
I had that as
I guess
the
that
hearts
was-
of power. That'd be like Care Bears or Captain Planet if
Well,
you're old
Didn't
enough to
Sailor
know.
Moon also have the heart?
Heart, symbol or whatever.
Yeah.
Yeah. I think I
think I
see
sent
but
it to you.
Yeah,
Yeah.
Yeah. So
And on the other side, I
Yeah.
can picture Melville's, Ahab stabbing at the whale, screaming about his, from the black heart of hell. Stab that thing.
that's a big heart there in that whale.
Yeah. But also, that's a deep target. He'd need to be very good with that harpoon to get anywhere near that thing.
He went crazy at the end. I think he was just
Yeah.
going out
He was
against better
unhinged.
judgment. He's out there doing it. But I maybe you know this reference. It came up. Especially the hearts as power and culture. Kingdom Hearts is a video game.
I love that game.
And the hearts are tangible. They could be stolen or corrupted.
You get the heartless, and
Right.
I mean, it's a super convoluted storyline.
story,
I don't
yeah.
recommend anyone trying to go through it and understanding it, but it was fun. I think I remember that being fun. That was
I still don't know what genre of game this is. Is this an RPG? Is this puzzle?
Kingdom Hearts is a Final Fantasy crossover with Disney. So
wow.
exactly,
Okay.
that is the convoluted part. And then the storyline, you get people from Final Fantasy games and Disney, and then you get an original character, which is Sora, and you can just get lost in the lore and then still don't know what's going on.
In my brain, that turned into, we have some bourbon in this glass, and we're gonna add heavy cream.
Yeah.
No, please don't.
Don't do it.
Yeah,
Like, it's cool to see the worlds that they go to, but there's so much filler of trash that it's so hard to get through all of it.
But you can trade hearts. So that's
No, you can't trade hearts. What are you talking?
or steal hearts.
I mean, there's a group that does that, yes,
Oh, okay.
but not you.
Oh, you
You're-
don't do it. All right. So
No,
someone else steals
you're
your
working
heart.
with Disney, and
Okay. I don't know you're working
You got
with.
Mickey Mouse
I didn't play this
coming.
game. The Mickey Mouse isn't on the black market stealing hearts.
no, but he's in a dark hood. I don't know.
Yeah. I think he's up
Mickey's
to
in a
something.
dark hood.
Yeah, he
Oh.
goes through his emo phase.
There you go.
Wow. I had no idea.
No, and then those were in there. That's all I had. And Gothic hearts, vampires, but we did the Telltale Heart.
I have one more
idea.
piece I'll add. Healing factors when it comes to hearts.
Healing factor. Yeah.
Yeah,
Mhm.
because when we run our heart ragged, it has to heal. It literally takes damage, right? This is like athletes will actually undergo remodeling of their heart. So when somebody starts running more and more, their heart will get bigger and a little bit beefier and whatnot. But the way that happens is it's literally getting injured on a subcellular scale. Here and there, little tears, things are breaking, and it releases chemical signals that brings in machinery to build more. And that's how it's getting bigger. So recovery times are super essential. This is something that either the superheroes would have to be taking breaks after every big exertion, or they've all got a little bit of a healing factor through one means or another, whether Wolverine style built in or, just injecting something that treats stuff.
But that's
So
like all their muscles, though. That's every muscle. Like if you're the Hulk throwing cars or whatever, you're getting a bunch of micro tears and you have to then recover. So the heart is just another example. And you had the real world example of athlete. When you weight lift, that's what you're doing. You're actually causing micro tears, and then your body rebuilds stronger and builds more muscle. So and you're right. If you go to that next extreme level, the athlete, a professional athlete, then you go beyond that to superhero, you're right. And that's that point that I think there's a lot of characters in the fiction world that appear not to have super powers in some way, but I think that maybe they do. Maybe they have some other innate powers, and this weren't tested genetically. They are mutants, right?
The ones that fly around in space and spend extended times there, our hearts don't like absence of gravity. Look at what happens to people that come back from the ISS. They have some, remodeling of their hearts they have to reverse.
I mean, you also have lack of oxygen. There's a whole bunch of problems flying around in space. I mean,
When it gets really cold.
Here's a simple thing.
it's
Let's
cold.
assume they trap
And no one can
some
hear you
bubble
scream.
of gas around them.
yes.
But if they do that, do they know how far they're going to know how much
That's
air
right.
to pack? At some
That's-
point, does it get crazy?
Yeah. Yeah.
And also,
yeah.
if you're exerting inside that bubble, man,
that's
you
right.
better bring some nose
That
clips or
CO2,
something. It's going to reek in that.
Yeah. No, that's one of the things I think we touched on in a few episodes with the force field model, that you start hand waving them away.
Yeah.
These issues with the force field, but then no one takes, how do you get oxygen transfer? How do you scrub the air in there? You just fill it with CO2 and die. You will start to have other problems that you can't just wave away with that simple, we'll put a force field around them and then they can do whatever. And it's, no, you really can't. You're in trouble.
In the heat evolution, right? You're driving yourself to do all these things,
right.
fly fast, lift stuff.
Yeah.
I mean,
you still run out of calories.
This team, Brandon Monroe did a beautiful video on, could you use a submarine as a spaceship? These things are built to be airtight. Could you just take one to space and would it work? And what he worked out was, no, it would absorb so much heat, it would cook the insides in no time. And every spacecraft we build half of it to deal with the amount of heat that they're dealing with.
Yeah. Cool.
Were you going to say something, Nick?
Yeah, so I did forget for a second. But when your heart tears and rebuilds, does it tear every time that you're doing that exertion or no?
It's tearing right now. It sounds scary, but it's not. It's just the more we exert, the more these micro tears happen. But the fact that it's beating right now means there are some tears happening. And like, I'm talking about tiny. There's a little puncture in the cell membrane. There's a whole bunch of things that proteins and stuff that come out and start patching it. It's just constant. It's like the Golden Gate Bridge. It's always being painted. It's always being torn, always being repaired. Sometimes the tempo is more.
That's why working out and things, it's helpful.
Yeah. I just didn't know if like, all right, I did this exercise really hard today, but I'm going to do it again 2 days from now. Is it still going to rip and everything or tear? Not rip, tear.
Yeah.
That's why I was like, is it just like, all right, it's new norm now.
Right. This is it.
So that's where a lot of exercise physiology science gets into, is how do you program your workouts and recovery periods in what ways to achieve desired target performance for whatever you're trying to do. And that's different if you're trying to say, be a power lifter versus a distance runner and whatnot.
Right.
But that's where a lot of this effort goes into, is in various tissues, not just the heart, muscles, your nerves are getting a little bit beat up and have to recover. That's why if you play like a really hard, tense game of something like basketball, you're not going to be able to play another one of those immediately after that. It's not, even if your muscles magically recovered, you won't have the reflexes.
Oh yeah, I totally get that with playing Dark Souls.
Actually, I was going to say video games. I have frayed my nerves while leaving my muscles untouched, just overdoing it with video games.
So
your
often,
heart rate, your anxiety, everything, you get it. No.
Oh yeah.
I can't wait for the new Resident Evil. My heart's going to tear.
It is tearing right now. Cool. All right. We've come to the end of the beats.
What would be your ideal superhero heart?
Absolute ideal superhero heart is something that, this is getting into full-on hand wavium, but that's the easiest out. It's saying that's a trans-dimensional heart. It's doing all of its energetic business in another dimension where it's got huge amounts of space to disperse with energy, like heat, clean up chemistry, and then it's just this tiny little chunk of whatever here, and it does everything I want.
That's
There
like
you go. There you go.
It's the TARDIS heart. That's what I want.
No, that's always my bailout is the dimensional kind of dumping ground.
I mean, it's the same game we play in image analysis. If you have a problem here, just create an extra dimension and dump the stuff
Just dump
out
it in there. Yeah. There's no free lunches in physics unless you got multi-dimensions.
And all those beings in that other dimensions. Oh, geez.
Well, that was the premise, just a throwback about this kind of idea, The Gods Themselves by Isaac Asimov, where they went and they realized that energy was we got free energy, but really they were taking it from this other dimension that was going to go supernova, kind of Big Bang theory. And it was like, hold on, something's taken from us now. Like it's this whole little, kind of a game. Yeah, it's fun. It's a good book. One of Asimov, one of my favorite Asimov's books, The Gods Themselves. But yeah, there you go. Multi-dimensional,
Always
energy dumps.
always.
I like it. Cool. All right. Is that any last thoughts, words?
Do you have any things coming up? Anything you want to plug?
I mean, other than some research papers from my lab.
Please do.
Yeah. I mean, we're trying to remember what just got, but there's something exciting. Speaking of hearts, we worked out what happens in patients with COVID that started getting new cardiac arrhythmias because of that. One of my former students was able to reproduce that effect in a mouse and figure out that it's literally your own immune system was doing the dirty work there. You didn't even, like, when we looked at samples from patients in a previous study, their hearts showed no sign of the virus having made it there in some of these patients. The ones with myocarditis, yeah, there's virus in those hearts, but the ones with just arrhythmias, it was just spike protein from the virus. But that's like a red flag to the immune system that says there's a foreign thing here, and the immune system goes after it and shreds the heart. And we figured out exactly how that happens and, you know, how that leads to AFib. So that's one good thing that's coming out soon. Yeah.
Very cool. Yeah. We'll put a link to your lab's webpage. It's got cool stuff on there, and yeah, you should check out what Sai does. It really, you know, a bioengineer is what I like to call him. That's yeah. So a tinkerer. So.
Thank you so much for being here with us today.
We gotta have you back.
Thank you. This was so much fun.
Yeah. I'm a fan. So Sai always comments on episodes and things like that on LinkedIn, which is a professional page, but that's where he hangs out.
Wait, we have a LinkedIn?
No, the podcast doesn't have a LinkedIn. Maybe we should.
Yeah, you did know?
Yeah, that's right.
I wouldn't have been surprised with Joe.
No, maybe it needs a LinkedIn page. I don't know. We'll see. But yeah, no.
I think that's absolutely a great forum on which to connect with people who'd listen to this kind of thing.
Yeah.
That's a good
there
point.
it is. So maybe I'll break off from my own page, my own fandom.
Yeah.
Well, cool.
I don't know. There's a lot of us geeks in academia.
There are. No, yeah. This season we've had a ton of great guests from academia come in, and yeah, hopefully you'll join us again. I think, I know you like heart and we're thinking about this episode, but we've had conversations over drinks at the bar at a conference about just comic book stuff. So not even science. It's just, did you read this new indie comic? Did you read this one? And yeah, so it was just fun. So I thought, that's what we want, people to have fun with science, be curious.
And I can't believe I made it to the end of the episode and I didn't bring up Batman. I feel like I have betrayed 6-year-old me badly.
Oh no.
There it is. All right, so
maybe we'll have to do
right. We got to do another Batman episode. Maybe. That's
absolutely.
That's what Sai's setting up. He's like plugging for a new. You know what? I think you have to talk about my favoriteest superhero ever. So you got to have me back. Cool. All right, I think we're gonna leave it there and keep you hanging on the seat for the Heart of Batman episode.
Don't you mean hanging on the ledge?
Hanging on the ledge.
Off the gargoyle.
Always something else. He's never on a seat. Come on.
Batmobile, he's in a seat. Yeah.
No,
or the
he's just
Batcopter or the Batwing.
He's just squatting constantly.
He's got a bunch of vehicles he can sit on. All right. On that note, you have me, Joe.
You got Nick.
We've got Nick.
Georgia.
We've got Georgia.
And we went down some. Oh.